My name is Osama Awad Al-Kareem. I'm a professor of engineering science and mechanics. I'm also the director of the Center for Nanotechnology, Education and Utilization at the Pennsylvania State University. I have prepared and I'll be presenting this course, which is in the area of nano and micro electromechanical systems and smart structures. This course is about 30 lectures, and these 30 lectures will cover different areas of this topic. I will start in this preamble by giving a list of abbreviations that I'll be using throughout this course, as well as some definitions of some terms that would show up during the presentation of this course. First, we start with the abbreviation, or the term that I will use very often, ICs. That stands for integrated circuits. And the material that I'll be teaching in this course also has some kind of relationship to integrated circuits. So we will hear the word integrated circuits very often in this course. The second two terms that I'll often use in this course are the terms NMEMS or MEMS. NMEMS stands for Nano Electromechanical System. MEMS stands for Micro Electromechanical System. This is a definition here, if you like, the third bullet. What do we mean by a NMEMS or a MEMS? It's a system, either it's a nanoscale system or a microscale system, and this system contains nano or micro sensors, nano or micro actuators, in addition to IC processing unit or units. Also, another definition which is in bullet number 4 here, and this definition is what we mean by a NEM device or a MEM device. NEM, that is nano electromechanical device, or MEM device, which is micro electromechanical device. And we mean, literally, we mean by a NEM device or a MEM device, a single device which may be a nano or a micro sensor, or a nano and a micro actuator, nano or micro actuator. So a NEM device may be a nano sensor or a nano actuator. A MEM device may be a micro sensor or a micro actuator. Typical NEM or MEM device size. NEM, that is a nanoscale device, is 1 nanometer to 100 nanometer length range. And a MEM device, that's a micro electromechanical device, the range is anywhere from 0.1 of a micrometer to 1 millimeter, which is 1000 micrometer. Now, before I leave this slide, I would like just to explain what I mean by the terms micro and nano. I believe most of you know what these terms are, but just to be sure, that we covered everything. Micron, 1 micron is actually 1 times 10 to minus 6 meter. So a micron or a micro scale is 1 times 10 to minus 6 of a meter scale or a length. On the other hand, 1 nanometer is 1 times 10 to minus 9 meters. So these are the kind of length scale that we're talking about. 1 millionth of a meter for a micro scale, 1 billionth of a meter for a nano scale. And in the notes page, let me just highlight, some of the terms we use. Here are micro and nano, as well as terms like NMEMS and MEMS. These are terms that would show up very often. So these are some of the important terms or abbreviations that I would leave you with in this slide. So the last slide in this preamble is a slide that describes the course outline. This course will cover different topics over these 30 lectures or so. We will talk about materials that are important to NMEMS and MEMS, important to, of course, ICs. ICs is very much related to NMEMS and MEMS. Then we will be talking about fabrication processes, processes that are used to make NEM or MEM devices, or NEMS and MEMS, meaning systems. That is to say, a group of devices. And these fabrication methods or processes are included within these topics here. So in these topics, we will be covering bulk, nano machining, and micro machining. So that is to say, machining at the nano and the micro scale. First of all, we will talk about bulk type of nano or micro machining, and then we'll be talking about surface type of nano and micro machining. And then the 2 additional processes that we'll be discussing in this course are the LIGA process, which is a German acronym for lithography, galvanoforming, and abforming. And that is where the word LIGA comes from. And then an offshoot or a product of LIGA with a little bit of modifications called sacrificial LIGA process, S-LIGA processes. So these are basically the fabrication processes that are used in NEMS and MEMS and smart systems or structures. Then after that, the course will cover different types of nanosensors and microsensors. And these will cover different types of sensors, thermal sensors, radiation sensors, mechanical sensors, magnetic sensors, as well as biological and chemical sensors. So we will be going through different types of these sensors. How do we fabricate them? How do we make them at the micro scale or the nanoscale? And what are the properties that are utilized in operating these sensors. Then after that, we'll be talking about micro actuators and nano actuators. So both scales of actuators will be covered. Again, how we make these actuators and what are the principles of operation of these actuators. And then eventually, and in the last chapter, we'll be talking a little bit about integrating these sensors, actuators, and the IC processing units into a system, which is that completes, an overall system which performs a particular task. So these 3 slides, if you like, are a preamble or an introduction or a preface to this course, which would be covered in the rest of these lectures.